Next, turn to page 20 for the chapter exercise. Let's look at the multiple choice. Number 10. When we heat sodium and put it in a gas jar containing chlorine, a reaction takes place immediately. Which of the following substances does not belong to the system? System, that means are the reactants and the products, okay? Sodium reacts with chlorine. Do you remember? Can you guess what is formed? Sodium chloride is formed, okay? So, let's look at the answer. Sodium is one of the reactants, therefore it belongs to the system. Chlorine is also a reactant, therefore it belongs to the system. Sodium chloride is the product, therefore it belongs to the system. Gas jar does not belong to the reactant or product, it is the surrounding. Therefore answer is dog. Answer is dog. Number 11. The change in internal energy and enthalpy change of the reaction are respectively. What is the work done on the surroundings by the reaction? Now, by using the reaction, enthalpy change, that is, maybe I write down the equation first. Enthalpy change is equal to the change in internal energy plus work done on the surrounding. Bear in mind this equation, okay? So put the data into the equation. Negative 211 is equal to negative 256 plus work done, W. I use capital letter W. W therefore is equal to 256 minus 211, which is 45 unit kilojoule. Now, if the work done has a positive sign, that means work is done against the surrounding. Energy is needed against the surrounding. If we have a negative work done, what does it mean? Work is gained by the system. Okay? Here we have A. A is the answer. Number 12. In which of the following reactions is their heat change measured at constant pressure? Constant pressure is almost the same as the change in internal energy. Now again, let's use this equation. That is, enthalpy change is the heat change at constant pressure. Bear in mind, enthalpy change is the heat change at constant pressure. I repeat, enthalpy change is the heat change at constant pressure. Now, let's look at the question again. The question asks us to predict in which situation enthalpy change, because here it is mentioned at constant pressure, is almost the same as the change in internal energy. Let's use this example. This is the enthalpy change at constant pressure. If it is approximately equal to change in the energy, that means work done should be equal to 0. When will be the work done is equal to 0? There is no change in volume. No change in volume of the gaseous. Bear in mind, gas. I must emphasize gas. Now, let's use the first one to illustrate what I'm talking about. It is a solid. It is a gas. We have 1 mole of gas in the reactant side. And then let's look at the product. the product is carbon dioxide. Again, it is a gas. Besides, the number of mole is also equal to 1. That means there is no change in the number of mole of gaseous molecules. So there is no change in volume. In other words, work done is equal to 0. Work done is equal to 0. Because there is no change in the number of mole of gaseous molecules, therefore there is no change in volume. Let's use question number 2. Here, gas, gas, and gas. Here, altogether, we have 3 moles of reactant. In the product side, we have only 2 moles. That means number of moles of molecule decrease. In other words, the volume of gas decrease. Volume of gas decrease, that means work is gained from the surrounding. There is work done. Work done, although work is gained, it will have a negative sign. Enthalpy change is not approximately equal to the change in internal energy. Lastly, let's use number 3. Aqueous, aqueous, aqueous liquid. None of them is in gaseous state. That means there is no change in gaseous volume. Therefore, work done on the surrounding is equal to 0. Look at the equation. So, enthalpy change, which is the heat change at constant pressure, is approximately equal to the change in internal energy. Now maybe let's turn back to this page. This page to help you to understand. Now let's look at this example. Solid, aqueous, gas, aqueous. Okay? Neglect the solid and the aqueous reactants and products. Focus only on the gaseous. In this situation is the product. As hydrogen gas is formed, work must be done against the atmospheric pressure. Do you understand? Work is done against the atmospheric pressure. Okay? Now, heat change at constant pressure is not approximately equal to the change in internal energy because it involves work done on the surrounding. Okay? For this example, SO2, O2, SO3, you must focus on the state. Imagine in the flask we have 2 moles of SO2 and 1 moles of O2. And imagine there is an imaginary piston. It represents the atmospheric pressure. As the reaction proceeds, less gaseous molecules is produced. We have only 2 moles of it, 2 moles of SO3. So, look at the imaginary piston. Now the imaginary piston pushed down from A to B. From A to B, pushed down. In this situation, work is gained, okay, from the surrounding to the system. Compare with this situation, we have an expansion of gaseous volume. During the expansion, work is done against the atmospheric pressure. Work is done against the surrounding. This diagram is easier to understand. Try to understand this diagram first. If there is an increase in the number of mole of gaseous product, then work must be done against the atmospheric pressure. On the contrary, if there is a decrease in the number of mole of gaseous molecule, work is gained from the surrounding. You understand? Next, question 13. Which of the following processes are exothermic? Exothermic. Burning of tongue gas. Use your experience. You know that heat is released. Okay, so it is an exothermic reaction. Reaction between iron 2 sulfate and aqueous ammonia. Do you remember what is the reaction? We have iron 2 iron in iron 2 sulfate. We have a hydroxide ion in ammonia solution. Precipitation occurs. Do you remember what color is the iron 2 sulfate? It is dirty green in color. Okay? Because precipitation reactions occur, as I said before, precipitation is an exothermic process. Do you understand? And do you remember why ammonia contains hydroxide ion? Because ammonia reacts with water to form ammonium ion and hydroxide ion. This equation is useful in explaining why ammonia is a weak alkali. Weak alkali. Next, dissolving ammonium nitrate in water. Do you remember which example involved dissolving ammonium nitrate in water? Which is the cold pack. Let's refer to the video again. Cold pack. It is an endothermic process. Okay, therefore obviously the answer is A. Next, question number 14. In an endothermic reaction, energy is released to the surrounding. Energy is absorbed for bond forming. Bond forming processes give out more energy than that is needed for bond breaking, or enthalpy of products is higher than that of reactants. Now, because we are talking about the enthalpy level diagram, so let's draw the enthalpy level diagram. You must label the y-axis, which is the enthalpy. The x-axis is the reaction pathway. Actually, it is meaningless, okay? And then for endothermic process, enthalpy of reactants should be lower than the enthalpy of product, so that we have a positive sign of delta H. And then let's explain in detail. The energy released in bond breaking should be larger than the energy released in bond forming. Do you understand? So let's look at A. Is A correct? Because it is an endothermic reaction, so energy is absorbed. This term is wrong. Absorbed from the surrounding. This sentence is only true for exothermic reaction. B. Energy is absorbed for bond forming. Bond forming is an exothermic process. Therefore, in bond forming, energy is released. Therefore, it is wrong again. Bond forming processes give out more energy. Bond forming processes gives out less energy. It should be less, not more. Therefore, C is also wrong. Enthalpy of products is higher than the enthalpy of reactant. So obviously the answer is dot. Can you follow? Next, question number 15. For the following reaction, we have H2Cl2 and hydrogen chloride. Here we have one HH bond and one Cl-Cl bond. Finally, we have two HCl bond. Cl-Cl bond is broken during the reaction. Yes, it's true. Hydrogen-hydrogen bond forms was wrong, is broken. Hydrogen HCl bond forms during the reaction is true. Therefore, the answer is 1,3B. Can you follow? Lastly, number 10. Which of the following combinations is correct? Energy change in bond breaking process, energy change in bond forming process, and enthalpy. Now let's use this diagram again. Actually, enthalpy change is equal to the amount of energy, or maybe let's use this. Now please bear in mind this equation. Enthalpy change is equal to the energy change in bond breaking minus energy change in bond forming. Breaking minus forming. Bear in mind. Let's use this equation to understand this multiple choice. Energy change in bond breaking minus bond forming. Breaking minus forming. Okay? 100 minus 200. It is equal to negative 100. Therefore, A is wrong. This minus that is equal to negative 150. Therefore, it is wrong. This minus that is equal to positive 150. Therefore, again, it is wrong. This minus that is equal to plus 170. Therefore, it is correct. Try to remember this equation. You may enthalpy change is equal to the energy change in bond breaking minus energy change in bond forming. How to memorize? You may remember B first and then F next. Breaking minus forming.